Hey guys, so I've got something new to show you. I've been working on some wireless Arduino stuff, and I've got two little things here. This one is a receiver. I'll give you a little bit of a close-up in a second, and this one is a transmitter. They work on the 433 megahertz band, and they just have little crappy aerials. This one's curled up, it's about 30 centimeters long. And this one's about 25 centimeters long, and this one's kind of a monopole antenna, but basically it's just a straight bit of wire, and this one's curled up. I don't know why it should be curled up, it just said so in the data sheet. Now I assume it's got something to do with the frequency and the wavelength or something like that. I'm sure someone will be able to tell you. I've looked it up, but I didn't understand it. So I'm just going to tell you how you can connect these. Now it uses the virtual wire library, which is freely available on the internet. Just give it a search, you'll find loads of tutorials about it. But when I looked it up, I found it really difficult to get started. It was easy to send a standard char array of stuff, like a constant char. Is that what it's called? Something like that, anyway. But I wanted to send integer variables across it. In fact, I wanted to send a float. I wanted to use stuff coming from a potentiometer, and I wanted to use stuff coming from proximity ultrasonic sensor, and I also want to be able to send data from a Hall effect sensor, which I haven't bought yet, but I will do. Now, these little things here, they cost me £5 from eBay. Now, I really wanted to get them locally. Unfortunately, they didn't have them in Maplin, which is the closest shop to me. Now, I'd always recommend getting local stuff. If you don't buy it locally, eventually it will disappear and no one will stock it anymore. So it's a good idea to buy locally if you can, even if it means spending a little bit more money. But unfortunately these weren't available. I do try and get things locally where I can though. Now, these work with 3 pins each. So you've got 5 volt and ground, and you also have a data pin. And it does some kind of software serial thing. So it gets the data from your Arduino and sends it out to one of these and encodes it in an unsigned int with 8-bit encoding. So it's like a byte, and it will send that off over this wireless transmission thing. And there are various things in the library that ensure that the receiver realizes it's received the entire message before you do anything with it. Now, at the moment I'm using an ultrasonic sensor and receiving with this. So I'm sending a distance thing with the ultrasonic sensor and receiving it over here and displaying it over serial. Now, I'm using the Tellymate shield, which I showed in one of my other videos, which is a really good way of just seeing what's coming out on the serial monitor. And you can also format it so it looks nice and everything like that. But I can plug it into a TV, or in this case I've got one of those little portable LCD displays. And you can do various things, like you can send an integer, but you have to encode that to a string before you send it, and then you can turn it back afterwards, which was the difficult bit. That was really hard to figure out because I'm thick, and also because it's not well documented. Well, I didn't think it was well documented. Anyway, I'll show you the various bits and bobs all working together. At the moment I've only had it working about 5 meters. Now it's rated for around 150, some people have said it works at. 150 meters is a really long way, I think, but it could go even further if you use some different transmitters and different receivers. Now I got these because I was looking for an alternative to the XB modules that you can buy, because they're really expensive, and I just wanted to test the concept. Now if I was going to go ahead and change this project into something that I'm really going to use, then I'd probably invest in the XBs, because they have such a vast distance on them and they're less prone to interference. Really you need line of sight for these if you want it to go any distance, but if it's say in the next room, that's still fine. I'm hoping to make a sort of wireless telemetry system. Now people do this with radio controlled stuff all the time, but I want to do it in Arduino from scratch, knowing literally nothing about this kind of technology. So let's jump straight into looking at what I'm doing. You do need 2 Arduinos for this. I'll put the parts list in the description box below, so take a look at that, and if you have any questions, please feel free to ask. And if you like it, do that like thing on Facebook or subscribe or whatever it is. Alright. Right, so this is the receiver setup. And I've got my Arduino Mega right here and the Tellymate shield on top, which is feeding the output to here. And here's a little transmitter. Now, it's got quite a short aerial, and I imagine that's to do with the wavelength. I have no idea really. But on the other side of this wall, behind a radiator, 2 radiators in fact, and it's probably about 3 meters away, the transmitter is sat on my work desk through there. And it's sending it all out just using 5 volts. In fact, it's battery powered at the moment, so it's doing quite well. And the whole idea was it was going to be wireless telemetry, so it says the speed is 57, 58, it's oscillating a little bit. It's using a wireless potentiometer to just send a fake value, but it needs a bit of smoothing, it seems, because it's sort of oscillating around. So perhaps a resistor might do that for me. The distance to the next car is 0.4, and that's actually centimeters according to the ultrasonic sensor thing. Now you can see here that it's connected to 5 volt and ground, and it's diving into one of the digital pins there to get the information through. I did have it set up on an LED just so I could see that it was all received, but in the end this has worked out quite well. By the magic of video, I'm able to be in the other room changing the display at the moment by turning the pot so it changes its resistance, and also putting my hand in front of the distance sensor so you can see that number change as well. And it all changes very, very quickly, so these variables are being received by the Arduino and displayed on screen very, very quickly. So actually it's quite a high performance transmitter and receiver for such a small amount of money. Right, and this is the transmitter setup. So we've got the ultrasonic sensor here that detects the changes. We've got the tiny little pot there, which I can adjust with this screwdriver if I don't sort of mess the whole thing up. And so that's sort of acting as if it were a Hall effect sensor, so it's sort of sending some variables so I can display it on screen. And the Arduino is here, powered by just a couple of batteries. Now here's the transmitter just here, and that's connected to 5 volt ground and to a data pin, this one here. It's on pin 3 at the moment. Now all of the special stuff happens in the encoding. This is all just wiring things up. It's not very difficult, but I'll show you the encoding now. Right, so here's the code, and first off we're going to start by including the virtual wire library. Once you've installed that, you'll be able to see some examples at the bottom here, and there's client, receiver, server, transmitter. Now this one's the transmitter example, but padded out a lot with other bits. So I'm defining some things and defining some stuff. I'm starting off the sonar sensor here. This is the distance sensor. You may not need to do that. And I'm setting up some variables here to hold various things before I send them off. Now if I jump straight to the setup, virtual wire setup here is set to 2000 bits per second. You can reduce that to 1000. You may get a bit more range out of these things if you do that, but this should go to at least 100 meters according to documentation. Now I've only been able to test it to about 9 meters, but feel free to experiment. I've set the transmitting pin, the TX pin, that's to 3. That's sending the data out to the transmitter on pin 3 on the Arduino. Now in the loop I've started off with the delay and I've ended with the delay. Now this is just because I was looking at the serial monitor and I wanted to see what was going on. But a delay is rather useful. It means that you can allow your sensors to sort of reset and send another value, especially with the sonar sensor, which I think you need a delay of about 20 by giving it 50. So I'm setting up a few bits for that here. I've got a potentiometer on the Arduino Uno, so that I'm simulating speed using that. So I'm simulating a Hall effect sensor or a read switch, and I'm reading that on an analog pin just here. And because I want to get 2 digits from the thing, because I only want to send 2 digits of that number, I'm dividing that number by 11. The maximum that you can get out of a potentiometer on here is 1023, I think. So if I divide it by 11, then I get a nice manageable 2-digit number. But if the number goes under 10, it will be a single-digit number. So I'm rounding this number down on the potentiometer and on the distance sensor. But if it's under 10, I'm appending the value speed val with 0. I'm making the value of that string a 0 character, and then I'm appending the int onto the string. Now this probably isn't the best way of doing that. It might be more appropriate to use the ATOI, I think it's called, function to change the int into a string and then add it on. But at the moment this works fine using the plus equals operator, so I'm going to continue using it until someone tells me that I'm wrong. And it says if it isn't less than 10, it will just add that on there. And I'm doing the same for the distance one too. And again here, if it's the same thing really. Right, and what I'm doing here is I'm adding on a temporary holder. Now I was going to do this so that if for some reason it can't get any variables, it was going to send them on, but I didn't really finish that. So this is sort of just old code that you don't need to worry about. But at setting up the message here, I'm setting up an S as the first value in this string, and then I'm adding in the speed val, a D as the next one, and then the distance val. Now this is so that I can identify it if I want to as it comes into the receiver. Then I'm sending this string to a char array with a maximum number of spaces, places in the array of 27. That's because the virtual wire library only lets you send 27 bytes. And it does that because it can only send 30, and the other ones are just sort of checkers, so make sure that it's sending it's received a full message. Now then I'm resetting these values because I'm going to want to set them again on the next run through. I'm printing the message out here just so that I can check what's been sent, and here is where the virtual library sends it. It sends it as an unsigned int in 8-bit encoding, and it's sending sent values, which is what I've sent this here to, the char array to sent values, and it's discovering its length and sending it that way. And then there's a virtual wire wait, so that waits until the message has been entirely sent, and then there's another delay just so I can read the serial output. So okay, so we'll move on to the receiving code. So this is the receiving code. Again, we're including the virtual wire library, and we're going to be setting up some variables. You can ignore some of this code. This is for the Tellymate shield. If you've got one, then it's really important that you set some of these things up, and I would definitely advise you to get one. It's a great little piece of kit that enables you to send your serial data out and format it in a really nice way to a television. I'm using a small LCD display, like one that you'd have in a car or something like that, to look at my serial data. So it's a great way of visualizing what you're getting in the Arduino. Anyway, we've got some booleans here. This again is some code that I've started working on but haven't quite finished, and I'll explain that as we move on. Now in the setup, I've begun the serial at 57600, and that's fine for the Tellymate shield. So this is another bit of Tellymate code to stop the cursor showing up. Now the virtual wire library is set up at 2000 bits per second, again the same as the sending code, and I'm setting up the pin on pin 23 because I'm using a mega for the receiver, and we're starting the virtual wire library here. Now in the loop, I'm setting my variables, resetting them essentially, and I'm also setting up the buffer, and it says VW max message length. Now this is all set inside the library as I mentioned before, and as far as I know you can't change it. I'm sure some clever coder could do it, but that's not me. And then we're calling this here So it's looking for the message, and then it's setting it all in here. So, and this loop you can use if you want to get your data out, but I decided not to. I started using this to figure out when the variables had arrived. It's so that if I've got a message with loads of different variables rather than the ones I just know about, then I can look for them here, and I would look for the identifiers for S. And T was going to be temperature, but my temperature sensor hasn't arrived yet, so I've not started doing that. Now a bit further down, this is where we're going to print out the variables. Now I'm using some Tellymate code to send the cursor around the screen and place these variables where I want them to be. At the moment, I'm not bringing the variables in as ints, I'm bringing them in as strings or as characters in ASCII code. So I'm writing them to 0 rather than printing them. Because if I were to print them, it would print out as the numbers for the ASCII rather than writing them, and the Tellymate shield interprets them as characters. But you can change that if you want to and interpret these as strings if you want to, or you can bring them in as numbers. And you can use the AOTI function again to do that, or it's the reverse of that function, whichever one it is. Anyway, I know what positions my variables are. I know that in position 0 I've got the letter S, and I know in the next 2 positions I have 2 digits from my sensor, because I sent it all as a string into a char array, separating those characters out. And so I'm writing them out here, and I've put your speed is, and then I'm printing those 2 characters side by side. And I've done the same with the distance here, as you can see, position 4 and 5 from the array. Now there's some bits here where I've changed the text size, just to make it a bit more easy to read on the screen. So I'm printing them out twice, but I'm only printing the top and the bottom half. And then at the bottom I'm clearing the screen if it's only just started. This is a syncing issue with the Tellymate, meaning that some weird characters will show on the screen. And that's pretty much it. That's an easy way of pulling out some data. Now, it's not the best way, and I'm still working on a way to do that sort of automatically. As long as I know what variables I'm looking for here, what identifiers I'm looking at, I can pull this data out and then use the function to turn them into an int again. But I haven't completely finished that. But for now, this is what I've achieved, and hopefully this will give you some ideas on what you can do.